Hi, everyone. My name is Dr. Ryan Sandell, and welcome to the second lecture of this Introduction to Phonology at the Ludwig-Maximilians-Universität München. Good. So last week, we started to dig into some of the methods that are needed for carrying out the analysis of phonemes in a given language. And this week, we're going to continue to see some other topics concerning the analysis of phonemes. And we'll talk about things a little bit from something of a typological perspective. We'll get to that after we've kind of laid out what our basic theory of phonology in this course now looks like. So already last week, we talked about the notions of underlying representations in contrast to surface representations and how phonological rules can serve to derive allophones from underlying phonemes. And then one of our major topics today will then be the psychological reality of the phoneme. So we'll be concerning ourselves with the question of whether phonemes are just a sort of analytical tool for linguists that sort of simplifies our lives and tries to help us understand how linguistic systems work, or if these phonemes actually have psychological reality for speakers of the languages. That is, if they really represent mental entities for those speakers. And finally, at the end of today's course, I'll briefly touch on two topics that will start to emerge in some of the exercises and the homework assignments that we'll be seeing. These two topics, rule ordering and contextually limited contrast, we will both address to some greater extent later in the course, but they are topics which I think you should gain some familiarity with already at this point. So today, by the time you're listening to this lecture, it would have been good to read at least chapters 2 and 3 of Hay's textbook. And for next week, we will be dealing extensively with the phonological feature system presented in Hay's book. So you should read the following chapter, chapter 4. And the first homework assignment will be uploaded, available for you, for those of you who are following this course for credit, will be uploaded by the 29th of April. All right, so let's start off today by reviewing our phonemic analysis of the O'odham language that we carried out last week in order to get an idea of what our working theory of phonological analysis is. So last week, we developed an analysis positing two alveolar stop phonemes, t and d, or O'odham. And just for reference, let's have a brief look at some of the O'odham data again. That was in the handout from lecture 1. And you can refer to that above as I talk through the essence of the analysis from last time. So last time we found that the two alveolar stops, voiceless t and voiced d, were in complementary distribution with the palato-alveolar affricates ch and j. And in that case, we found that the affricates only occurred before the high vowels e, u, front e, back u, and central I. So for instance, we have words like bijim with j before e and chikid with ch before I, but otherwise in all other positions before non-high vowels or at the end of a word, for instance, we find the stops t and d. So we were able to conclude that these sounds, that the affricates and the stops constituted allophones of single phonemes. And for at least the affricates, we could find some instances of those affricates occurring in identical local contexts. So if we compare, for instance, data point number 7, the word for vaccinate, chikid, with the word jiweed, that's data point number 18, here, meaning soil or earth. We can see that the local context is identical, and that tells us that those two affricates, ch and j, ought to belong to distinct phonemes. So let's recall here that two sounds are said to contrast or be distinctive if they can be used to distinguish words semantically. So those two pieces of data in the O'odham words, chikid and jiweed, those don't constitute perfect minimal, that's jilid, don't constitute perfect minimal pairs, but because those two sounds occur in identical local environments, we can make, for the time being, the assumption that they probably are contrastive. And let's recall as well that the primary task of a phoneme within a linguistic system is to sound perceptibly different, at least for native speakers of that language, from all of the other phonemes, from all of the other contrastive sounds of that language. So this property is what allows phonemes to serve as the building blocks for distinguishing morphemes. So hopefully you're familiar with that concept from an introduction to linguistics or an introduction to morphology, and for distinguishing whole lexemes. And that's precisely why minimal pairs are useful. They help us to find, using semantics, basic meanings, what is probably phonologically contrastive. So since we saw that the two allophones, the two stop allophones, t and d, occurred in a wider range of contrast than the affricate allophones, it makes sense to posit those elsewhere allophones as the underlying representation for the phoneme, as the underlying form of that phoneme, and use a phonological rule to derive the palato-alveolar affricate allophones. And this was our rule of alveolar stop affrication, which simply states that an alveolar stop, which forms the which captures just the stops t and d as a natural class in Ordam, will become a palato-alveolar affricate, just in case it occurs before a high vowel. So here we'll use the feature, the phonological feature plus syllabic to identify vowels, and the feature high to pick out the group of vowels e, u, and u. So here what was important is that we operated with a theory of underlying representations, which holds that a single underlying form ought to be established for each phoneme. So when we find sounds that stand in a complementary distribution to one another, then we want to try to decide what the common representation underlyingly is for that sound. And sometimes we will talk about this underlying representation as the phoneme proper. So in the case of the voiceless alveolar phoneme for Ordam, we would say here that the underlying form, the underlying phonological content of that phoneme is an alveolar affricate, and that's at the phonemic level. Zoom out a little bit so you can read this. And at the level of the allophones, we had then these two further sounds. At the allophonic level, we have the two sounds ta and cha. At least those are the two major allophones of this phoneme ta that we can identify for Ordam on the basis of the data that we have. So this means then, given this theory, that every instance, say, of cha on the surface should correspond to an underlying ta, and every ja, every voiced palato-alveolar affricate ja, ought to correspond to an underlying voiced alveolar stop, then it means whenever we see one of those affricates in the surface form of a word, so take data point number 1, bijim, or data point, the word chuku, not quite sure where that is now. That's data point number 11, verb meaning become black. Then we should, for the underlying representation of those words indicated between slashes, we should simply replace the affricate with the corresponding stop. And then by the application of our alveolar stop affrication rule, we will then obtain the affricates in the expected position. We're able to predict the occurrence of those allophones. In other words, what our alveolar stop affrication rule is also saying is that, the appearance of the palato-alveolar affricates are completely predictable in this language, whereas the occurrence of the elsewhere allophone, the alveolar stop allophone, is not wholly predictable. And that's precisely why we choose the elsewhere allophone as the underlying representation. And let's take one other little reminder here, is that a phoneme is going to be an underlying entity from which sets of non-contrasting sounds may be derived. So precisely when sounds stand in complementary distribution to one another, when their occurrence is determined by phonological environment, then they can't be used to distinguish the meanings of morphemes or whole lexemes. They're simply not contrastive. So to take a couple other instances, the English diphthongal vowel O and its monophthongal form O are not contrastive. So in general, in English, in fact, we would probably, most varieties of English, my variety, for instance, we would posit the diphthong as the underlying representation, and the monophthong O just appears before a lateral sonorant. So words like cold, hold, bolt have a monophthong, but in other words that have this O phoneme, it's diphthongized. And we've just seen how tohono o'odam works. And in German, for instance, and this actually pretty much goes for most varieties of English as well, there is no distinction between aspirated and unaspirated voiceless stops. And as we've seen in exercise last week, we tend to find the aspirated stops at least preceding vowels when they aren't also preceded by a sibilant. So from the elements of the aortum analysis that we carried out last week, and which I've just reviewed now, we can more or less describe how our hypothesis about the phonology of languages in general should work. So here are the elements of our theory. So the first piece is we have the notion that languages at the phonological level have words, morphemes. Not going to concern myself with the niceties of morphological and syntactic structure here, so we'll just say words for the moment. So we'll say that words are constructed out of a limited number of contrasting sounds, and we can think of those as building blocks, and those are the phonemes of a language. These phonemes themselves consist of little bundles of phonetic features. We're going to talk more about features next week, and these features serve to group sounds into natural classes. And again, next week when we talk about the feature system in more detail, we'll see how the natural classes are language specific. So for instance, using the simple features stop and alveolar to identify the manner and place of articulation in Ordam, we can make a natural class out of the sounds ta and da. And these phonemes, when they are realized on the surface, they can have different variants, which we call allophones. And using the method of local contexts to determine if a complementary distribution exists, we can detect this variation and see which of those allophones is essentially predictable. Then at that point, under the assumption that all words have a phonemic representation, so that was point A here, we can then posit an underlying form or underlying representation for each lexeme or morpheme of the language, which will consist of only the contrastive phonemes. So whatever allophones we have found to belong to the same phoneme can all be then represented as just a single phoneme. So this was the point above where we said for Ordam, wherever we find cha or ja on the surface, for the underlying representation of those words, we ought to replace it with the corresponding stop, ta or da. And finally, the last step is to use a phonological rule to derive the surface form of an utterance by, for instance, altering feature values or deleting segments, inserting segments. Thus far, we've only seen rules of this type, rules that alter properties of a sound. And that's precisely what the alveolar stop affrication rule here does. It changes both the place and manner of articulation of those underlying alveolar stops. Good. So when we come back, we'll start to look then at how the analysis of phonemes a little bit from a typological perspective.